Hi everyone, let's do IXL 7th grade A4. Go to Learning, make sure you're on Math, go down to 7th grade, then click on A4, Divisibility Rules. Okay, is 678,430 divisible by 5? What do we mean when we say that a number is divisible by something? That means if I divide this number by 5, I get a whole number. That is, I'll get a number without a decimal at the end, like 0.2 or 0.3. And let's go to the reference pages to see how we can figure that out. We have divisibility here on page 1. So let's scroll down to page 1, and here it is, divisibility. I'll make that larger so we can see it. And here are all the divisibility rules that you're going to need for this exercise. So to see if a number is divisible by, and then just go down to the number that you want to know about. So for this problem, we want to know how to figure out if a number is divisible by 5. So over here, let's go to 5. And we see that the rule for that is to see if it ends in a 0 or 5. So let's go back to this number. This number ends in a 0. So yes, that means it will be divisible by 5. So again, and you can check that on the calculator, 678,430. If we divide it by 5, then the result is a whole number. I did not get a decimal at the end here, like 0.1 or 0.2 or 0.628 or 0.7 repeating or whatever. I just got a whole number when I divided 5 into 678,430. So that means that that number is divisible by 5, so we will click on yes and go to the next question. Is 190,412 divisible by 10? Well, how can we figure that out? To see if a number is divisible by 10, all we have to do is see if it ends in 0. Well, this number over here does not end in 0. It ends in a 2. So that means if I were to take this number and divide it by 10, we don't even need the calculator for that. If we take 190,412 and divide it by 10, then really all we have to do is take this and move it one space to the left when we're dividing by 10. And our answer would be 19,041.2. So you see, we would get a point something at the end. It would not be a whole number. And that means that 10 does not go nicely into 190,412. So this number is not divisible by 10. So we will click on no. And again, an easy way to check is to see if a number is divisible by 10 is just look at the very last digit. It must be 0 for the number to be divisible by 10. And I'm going to point out here, I might as well say it because you probably guessed, yeah, you could just type these numbers into the calculator and see if you get a whole number or not as your answer. But it is good to know these rules, especially if you actually have an interest in math, and then maybe later in life you get interested in number theory, then it's good to know how to tell if one number is divisible by another. So let's move on. Is 62,736,000 625 divisible by 2. Can I take this number and divide it by 2 and then get a whole number? That is a number with no point something at the end. Well, it's actually pretty easy to check to see if a number is divisible by 2. We just have to see if it ends in a 0, 2, 4, 6, or 8. Now this number does not. It ends in a 5. So that means that when I take that number, 62,736,625, and divide it by 2, I'm going to get a decimal at the end. So you see I have that 0.5 at the end there. Okay, so we're going to say that this number is not divisible by 2. Is this divisible by 5? To see if a number is divisible by 5, we just have to see if it ends in a 0 or a 5. This number does end in 5. So if I take this number and divide it by 5, I know that I will get a whole number as my answer. So it is divisible, so we'll click yes. Is this number divisible by 9? Now what's the rule for 9? What's the rule to check if something is divisible by 9? We add up all the digits, and you should add up all the digits and see if you get a number that is divisible by 9. For example, to check 559, do 5 plus 5 plus 9, which is equal to 19. So we took the digits in this number, which were 5, and then another 5, and then a 9, and we added them up. So 5 plus 5 is 10, plus 9 is 19. So we got 19 as the result there. And then we have to ask ourselves, is 19 divisible by 9? Now, hopefully, after you add all these numbers, you get a number which is much easier to tell if it's divisible by 9. So I know that 9 does not go nicely into 19. The multiples of 9 are 9, 18, 27, 36, and so on, right? So all I have to know at this point is my 9 times table, and I know that 19 is not in the 9 times table. 9 does not go nicely into 19. So 19 is not divisible by 9, but therefore, according to this rule, the original number that we had, 559, is also not divisible by 9. So let's apply that rule to this number over here. So what we're going to do is just add all of the digits together from this number. So we have 6 plus 4 plus 5. By the way, I'm not going to prove why all of these rules work. There are good reasons why all these rules work. If we're doing this in class, then I would talk about that. But for this video, I'm just going to show you the rules and how to use the rules. So we're going to take the digits in this number, and we're just going to add them up. So 6 plus 4 plus 5 plus 7 plus 6 plus 3. And let's see what we get. Is there an easy way to add these up? Yeah, we could make things easy for ourselves by adding numbers that we know will add up to 10, because 10 is a number which is pretty easy to add with other numbers most of the time. So I know that 6 and 4 add up to 10, and I know that 7 and 3 add up to 10. So let's add those together. And then we still have a 5 and a 6 from here and from here. Remember, it is okay to add the numbers up in any order that is most convenient for you because of the commutative property, which says that for addition and multiplication, we can add in any order, and it's okay because we'll get the same answer no matter what. Now, the rest of this is pretty easy. So 10 plus 10 is 20, right? That was easy. 5 plus 6 is 11. So we have 20 plus 11, which is 31. Okay, Now, what's the next thing that we have to do? Now we have to ask ourselves, does 9 go nicely into 31? Well, what are our 9 times tables? 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So we skipped over 31, right? 9 does not go into 31, and therefore 9 also, according to this rule, does not go into the original number, 645,763. And again, we can check that. If we do 645,763 divided by 9, then we will get some decimal answer. You can see we get 0.4 repeating at the end of our answer. So we're going to click no, this number is not divisible by 9. Okay, is this number divisible by 3? Going back to these rules, the rule for 3 is actually very similar to the rule for 9. We add up all the digits and see if we get a number that is divisible by 3. For example, to check the number 825, we do 8 plus 2 plus 5, which is equal to 15. And 15 is divisible by 3. 3 goes into 15 5 times, as you know. So the original number, 825, is also divisible by 3 according to this rule. Again, I'm not going to explain in this video why the rule is the way it is. I'm just going to show you the rule and some examples about using the rule. So let's apply the rule to this number over here. We are going to add the digits together, 8 plus 5 plus 5 plus 4 plus 0 plus 8. And let's see if we can add this in a way that is a little bit more convenient. Let's add 5 and 5 together first. That makes 10. So now we have 8 plus 10 plus 4 plus, we don't even need the 0, right? Because adding 0 to anything doesn't change it. So let's just add 8. Is there any other thing that's convenient? Well, actually, I know that 8 plus 8 is 16, and 16 plus 4 is 20. So that was a little bit of mental math. So now we have 20, plus we still have this 10 over here. So our final result, 20 plus 10, that's going to give us 30. Now we have to ask ourselves, does 3 go nicely into 30? And of course, yes, it does. 3 goes into 30 exactly 10 times. So 30 is divisible by 3. And therefore, the original number, 855,408, is also divisible by 3. So we're going to click yes for that one. And you could check that in a calculator. You could take this number and divide it by 3, and you would see that you would just get a whole number for your answer. No decimal digits at the end. I should say no digits after the decimal place, after the decimal point. Okay, next question. We have another 9 one. All right, so these can be tricky. So even though we did it, and even though the last problem was also similar with the rule for 3, let's just do one more of these, and then we'll skip ahead to the next level. So we're going to add up the digits, 2 plus 8 plus 8 plus 0 plus 4 plus 1. Remember, this is the rule for 9 and 3. You don't have to do this for every other number. You might have to do it for 6 also. If it gives us a 6 question, then I'll get to that also. But you don't have to add the digits up for every single one of these problems. Let's see, is there a convenient way that I can add these? Well, actually, 2 plus 8 is 10, so that was pretty good. Plus, I can ignore the 0, because the 0 doesn't even do anything, so I don't even have to worry about adding 0 to this. And then I have to add 8 plus 4 plus 1. So let's just do that all at once. 8 plus 4 is 12, plus 1 would be 13. So we have 10 plus 13, which is 23. And now we're going to ask ourselves, does 9 go into 23 nicely? And no, it does not. And therefore 9 also does not go nicely into 288,041. So the answer for this one is going to be no. Okay, is this number 2,408,431 divisible by 4? Let me just check to make sure I am recording here. Yeah, I'm recording. Good. Sometimes I get worried that I'm just talking to myself. Okay, so what's the rule to see if a number is divisible by 4? Let's go over to the reference pages, and here's 4 right over here. So to check if the number is divisible by 4, all we have to do is check the 2-digit number at the end and see if it is divisible by 4. For example, to check the number 97,005,328, boy, that's a big number, all we really have to do is check 28, which is the 2-digit number right at the end. And 28 is divisible by 4, so the original number, 97,005,328, is as well. It is also divisible by 4, right? 4 goes into 28 7 times, and then that's it. So let's apply that rule to this number over here. So I don't even need these digits. All I'm going to check is this last 2-digit number at the end, 31. Does 4 go nicely into 31? Remember your 4 times tables. 4, 8, 12, 16, 20, 24, 28, 32. 4 goes into 32 8 times, but 4 does not go nicely into 31. So we're going to click no for this. Is 11,553,144 divisible by 8? Now the rule for divisibility by 8 is actually very similar to the rule for divisibility by 4. Here's the rule for 8. Check the 3-digit number at the end and see if it is divisible by 8. For example, to check 4,260,520, just check 520. That's the 3-digit number at the end. 520 is divisible by 8. You can check that with long division. So the original number, 4,260,520, is also divisible by 8. So it's very similar to the rule for checking if a number is divisible by 4. For 4, you're just going to check the 2-digit number at the end. For 8, you're going to check the 3-digit number at the end. Okay, so let's apply that rule to this number. The 3-digit number at the end is 144. Is 8, or does 8 go nicely into 144? Is 144 divisible by 8? Well, let's check that with some long division here. So I'm going to do 144 divided by 8. 8 does not go into 1, so I can put a 0 there. 8 times 0 is 0, subtract 1. Bring down the 4. 8 goes into 14 one time. 1 times 8 is 8. Subtract, we get 6 here. Bring down another 4. 8 goes into 64 exactly 8 times. 8 times 8 is 64. Subtract, we get 0, and there's nothing else to bring down, so we're done. And we did get a whole number here. Let's not worry about the 0 in front. We got a whole number, 18. So 8 is divisible, or I should say 144 is divisible by 8, and therefore, according to our rule here, the original number, 11,553,144, is also divisible by 8. So we will click yes for this. And again, you can check this in a calculator very easily just by taking that number and dividing it by 8 and seeing if you get a whole number. So you can see here we got kind of a big crazy number, right? But it's not a decimal number, it's a whole number. Okay, by not being a decimal, what I really mean to say is there are no non-zero digits after the decimal. It's not 0.7 or 0.6 or 0.0429. You know, it's just a whole number. So yes, this number is divisible by 8. Okay, this is a new one. Is 60,976,658. So we're getting a little bit of practice just reading numbers in this exercise also. Is that number divisible by 6? Well, what's the rule to see if a number is divisible by 6? Here it is right over here. Here's 6. Make sure it is divisible by 2 and 3. So actually, to see if a number is divisible by 6, I have to remember the rules for 2 and 3. So recall that to see if a number is divisible by 2, we need to see if it ends in 0, 2, 4, 6, or 8. To see if a number is divisible by 3, we need to add up all the digits and see if that result is divisible by 3. So let's look at this example over here. For example, 34. So what if I wanted to see if the number 34 is divisible by 6? Does 6 go nicely into 34? Now, hopefully, if you know your times tables, then you know that it doesn't go nicely into 34. But let's just also use this rule to check. So the rule says we have to make sure that it's divisible by 2 and 3. Well, 34 is actually divisible. I don't know why that's happening. Anyway. 34 is actually divisible by 2 because it ends in 4. Remember, to see if a number is divisible by 2, we just see if it ends in 0, 2, 4, 6, or 8. But that doesn't necessarily mean that it's also divisible by 6. So the other part of the rule is I have to also see if it's divisible by 3. So to check if it's divisible by 3, we have to add up the digits, 3 plus 4, because our original number was 34. So 3 plus 4 is 7, and 7 is not divisible by 3. So 34 is not divisible by 3, and therefore also not divisible by 6. So even though it is divisible by 2, that's not enough. According to this rule, it's got to be divisible by 2 and 3. So I have to apply both of these rules to every number that I'm trying to determine if it's divisible by 6. So let's go back to this number over here. Is this number divisible by 6? Well, is it divisible by 2? That's the first question that I'm going to ask. Is it divisible by 2? So I'll put a little 2 with a question mark there. And for that, I just have to check the last digit. If the last digit is a 0, 2, 4, 6, or 8, then it is divisible by 2. So we have an 8 here. So yes, it is divisible by 2. But I also have to check, is it divisible by 3? And in order to do that, I'm going to have to add up all of these digits. So let's do that. 6 plus 0 plus 9 plus 7 plus 6 plus 6 plus 5 plus 8. Let me just check. Did I copy that correctly? Because if I didn't, I might be in trouble. 9, 7, 6, 6, 5, 8. Yeah. All right. So let's go ahead and add these over here. So I see some numbers which I can add up and get a nice answer. 9 plus 6 plus 5. So I know that 9 plus 6 is 15. if I add 5 to 15, that would give me a nice 20 over here, so that's good. Is there anything else that'll be pretty nice? Yeah, actually, if I do 6 plus 6 would be 12, and 12 plus 8 would give me 20. So I get another pretty nice number here, 20. Okay, so far so good. What other numbers? What numbers have I not used yet? I have not used 0, but adding 0 to anything doesn't change it, so I don't even have to worry about that. What other numbers did I not use yet? I think just this 7 over here, and did I use... I used this 6 and this 6, right? I think I used all the numbers. Okay, so just plus 7, okay. Yes. Okay, yeah, so that's going to give me, so 20 plus 20 plus 7 is 47. So now I have to check, does 3 go nicely into 47? And the answer here is no, it does not go nicely into 47. And by the way, if you didn't know that off the top of your head, if 3 goes nicely into 47 or not, you could just apply the rule again. So we could apply the rule to 47 and we could say 4... Let me try that again. 4 plus 7 equals 11. And then I could ask myself, does 3 go nicely into 11? Well, 3, hopefully you know that 3 does not go nicely into 11, and therefore it also does not go nicely into 47, and therefore it also does not go nicely into 60,976,658. So we did a lot there, so let me just remind you what we did. To check if this number is divisible by 6, I have to check to see if it's divisible by 2 and 3. It is divisible by 2, and I know that because the last digit is an 8, but it is not divisible by 3. That's what we just checked over here. So since it is not divisible by 3, it is also not divisible by 6. So we'll click on no there. And again, we can check that pretty easily here just by doing 60,976,658 divided by 6, and you can see we get this 0.33333. So we get a 0.3 repeating there. Okay, so we don't get a whole number for our answer. So the answer for this problem is no, this number is not divisible by 6. Submit. Whew, took a while, right? Okay. So now we have a problem. This is more of a thinking problem. Type a digit that makes this statement true. So up to this point, if you've been cheating and just using your calculator for everything and not bothering to learn the rules, well, haha, now you're in trouble because now you have to actually understand what's going on. So pay attention here. Type a digit that makes this statement true. This number is divisible by 9. So if I put a 1 here, would it be divisible by 9? If I put a 0 here, would it be divisible by 9? If I put a 2 here, would it be divisible by 9? So what I need, let's remember the rule for checking if a number is divisible by 9. We have to add up all the digits and see if that number is divisible by 9. So let's put a question, well, I'll put a box here for the box there. So some number, right, I don't know what it is, I can put a question mark, plus 0, plus 6, plus 2, plus 1, plus 5. I want to put in a number here such that when I add up all these numbers together, my answer is divisible by 9. So what number should I put here? Well, it's easier if we first add up all of these numbers and then figure out what to do with this question mark over here. So let's see. 6 plus 2 is 8. I don't even have to worry about the 0. 6 plus 2 is 8. Plus 1 is 9. Plus 5 is 14. So I have 14 plus some number over here. Now I have to think of my 9 times tables, right? What are the 9 times tables? Well, 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. And I could go on, but I'm just going to stop there. So remember, my goal is to put a number in here so that when I add this and this together, I get one of these numbers over here, which I know is a multiple of 9. And so actually, what I could do is I could put the number 4 in here. Why am I putting the number 4 in here? Because I know that 4 plus 14, whoa, that's not what I wanted to do. Again, why am I putting the number 4 in here? Because I know that 4 plus 14 is 18, which is a number that is divisible by 9, because 18 is a multiple of 9. So I know that if I put a 4 in here, then the number 406,215 must be divisible by 9. Okay, and again, we can check that by doing this number divided by 9, and you'll see that you get a whole number result. But I'm not going to bother doing that now. Okay, type a digit that makes this statement true. This number, this whole number over here is divisible by 8. So what number could I put in here so that when I then divide this number by 8, I'll get a whole number answer? Well, let's remember the rule to see if a number is divisible by 8. All we have to do is check the 3-digit number at the end and see if it is divisible by 8. So what number could I put in here? It's actually easier than it looks, because these last 2 digits are zeros, which means, so I'm just asking myself, is 100 divisible by 8? Is 200 divisible by 8? Is 300 divisible by 8? And remember, we have the freedom here to pick any number that we want that we know would give us a number which is divisible by 8. So why don't I just pick 8 here? Because I know that 800 is divisible by 8. 8 goes into 800 exactly 100 times. So that's going to be my answer for this problem. Type a digit that makes this statement true. What number should I put here to make this number divisible by 5? Well, remember, to make sure that a number is divisible by 5, all we have to do is see if it ends in 0 or 5. And so all we have to do is put a 0 here or a 5, either one. So let's just put a 5 there and click submit, and that's it. Type a digit that makes this statement true. This number with some digit at the end is divisible by 2. Well, to see if a number is divisible by 2, we know that it has to end in a 0, 2, 4, 6, or 8. So if I want to make sure that this number is divisible by 2, I can just type in one of those numbers. So why don't I type in 4? And then I know that this number would be divisible by 2. And again, we can check that pretty easily. 17,646,764 divided by 2 would give us a whole number, which is what we want here for divisibility. Type a digit that makes this statement true. Okay, this one's a little bit tougher now. So we have to figure out if a number is divisible by 6, we have to know if it is divisible by 2 and also 3 at the same time. So what are the rules for that? Well, the rule for 2 is it has to end in 0, 2, 4, 6, or 8. The rule for 3 is we have to add up all the digits and see if the final answer is divisible by 3. So what I'm going to do to start out here is I'm going to add up all of the digits in this number. 1 plus 3. Let me start again. 1 plus 3 plus 5 plus 1 plus 6 plus 3 plus some mystery digit over here. That's the number that we're going to have to fill in. Let's add all of these together. Well, 1 plus 3 plus 6 would give me 10. 1 plus 3 is 4, plus 6 is 10. And then what other numbers do I have? 5 plus 1 is 6, plus 3 is 9. Plus my mystery digit. So 10 plus 9 is 19. So I have 19 plus some mystery digit. And I want the result here to be divisible by 3. Except I also want the whole thing to be divisible by 2. So that means since I'm choosing the last digit here, the only numbers that I could put in here, the only numbers that I have to choose from to replace the question mark are 0, 2, 4, 6, or 8, right? Because if I pick any other digits, then it won't be divisible by 2. So let's see. If I put, what if I were to put a 0 in here? If I put, meaning also a 0 in here, if I put a 0 in here at the end, then I know that the number would be divisible by 2, but it would not be divisible by 3, because 19 plus 0 is 19, and 3 does not go nicely into 19. So let's try again. I know that this number is not going to work. Let's try the next one. How about a 2? What if I were to put a 2 in this question mark box? Well, then I would get 19 plus 2, which is 21. And 3 does go into 21. So it looks like 2 is my answer here. Let's just remember why that works. Because if I put a 2 in here, well, remember the rule for checking if a number is divisible by 6 is the number has to be divisible by 2 and 3. Now, if I put a 2 in here, then I know the number must be divisible by 2, because any number which ends in a 0, 2, 4, 6, or 8 is divisible by 2. But also, if I put a 2 in here, and then I add up all the digits, and remember in this question mark, now I have a 2 instead of a question mark, then I get 21, which is divisible by 3, and therefore the original number, 1,351,632, is also divisible by 3. So I know by putting a 2 in here, this number, 1,351,632, would be divisible by 2 and by 3, and therefore also divisible by 6. So that is that we're going to hit submit here. And what? Oh, yeah, I didn't actually type it in, did I? I just wrote it in. Okay, so let me type in 2 there and then hit submit. All right, type a digit that makes this statement true. I think I'm going to skip this because we've done problems like this before. You have to add up these digits and then choose this number so that when you add it with all the other numbers, you get an answer which is divisible by 3, making your original number also divisible by 3. So I'm going to skip ahead to the next level. Okay, so it's a word problem now. A chain of car dealerships got a shipment of 947 160 new cars. There are the same number of cars in every color. How many colors could there be? All right, select all the possible numbers. So this question is basically asking us which of these numbers goes nicely into 947,160? Or in other words, 947,160, is it divisible by 6? Is it divisible by 5? Is it divisible by 9? Is it divisible by 2? It could be divisible by more than one of these. Let's check and see if it is divisible by 2. Well, it ends in 0, so I know that it must be divisible by 2. Okay, another easy number to check is 5. Remember, for a number to be divisible by 5, it just has to end in 0 or 5. And this number does end in 0, and therefore it is divisible by 5 as well. Is it divisible by 9? Let's see. To add up to check that, we need to add up all of the digits. So we have 9 plus 4 plus 7 plus 1 plus 6 plus 0. And let's see here. Okay, so 9 plus 6 is going to give me 15. And 4 plus 1 is going to give me 5. And then I have plus 7 also. And I don't have to worry about the 0. Now 15 plus 5 is that's easy. That's 20. So I'm going to get 27 here. Now 9 does go into 27. So, and therefore 9 would also go into this number according to the rule that's on the reference page. Now, is it divisible by 6? Well, to see if it's divisible by 6, I need to check to see if it's divisible by 2 and 3. I already know that it's divisible by 2. Is it divisible by 3? To answer that, I would have to add up all the digits, which I already did, and I got 27. And then I have to ask myself, does 3 go nicely into 27? Well, actually, yes, it does. It goes into 27 exactly 9 times. And since this number is divisible by 2 and 3, then it is therefore also divisible by 6. So actually this number is divisible by all of these numbers, so we're going to click them all and hit submit. A soda company makes different flavors of soda. Last year the company produced the same number of bottles of each flavor. If the company produced 54,252 bottles of soda in all last year, how many different flavors could the company make? So again, in order to answer this problem, really we have to know if these numbers go nicely into this number. So is this number divisible by any of these numbers? Well, let's check them one by one. Is it divisible by 3? So let's add up all the digits. 5 plus 4 plus 2 plus 5 plus 2. And let's see here. 9. I'm not really doing this in a convenient way. I'm just doing it one by one. So we have here 9 plus 7 is 16 plus 2 is 18. So remember, the rules for 3 and 9 are to add up all the digits, and then for 3 to see if the result is divisible by 3, and for 9 to see if the result is divisible by 9. So we added up all the digits, and now we just have to check, does 3 go into 18 nicely? Yes, it does. It goes into 18 exactly 6 times, so we can click on that. Does 9 go into 18 nicely? Yes, it does. It goes into 18 exactly twice, so we can click on that. Now, what about 4? To check if this number is divisible by 4, we don't add up all the digits. So actually, I don't need this anymore. All I have to do for 4 is check the 2-digit number at the end. Does 4 go nicely into 52? Well, let me check that with a little bit of long division. 52 divided by 4. Let's see. 4 goes into 5 once. 1 times 4 is 4. Subtract, we get 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12. Subtract, we get 0, and there's nothing else to bring down. So 4 does go into 52 nicely. It goes into 52 exactly 13 times. And therefore, it also goes into 50. Therefore, 4 also goes nicely into 54,252, according to the rule on the reference page over here. So we're going to click on 4. Now, what about 8? The rule for 8 is to check the 3-digit number at the end. And again, we're going to use long division here. So let's see if 252 is divisible by 8. If it is, then the original number, 54,252, would also be divisible by 8, according to our rule, which again, I'm not going to prove in this video. We're just practicing using the rule. So 8 does not go into 2, so we'll put a 0 there and there. Subtract 2, bring down the 5. 8 goes into 25 3 times. 3 times 8 is 24. Subtract there, we get 1. Bring down the 2. 8 goes into 12 once. 1 times 8 is 8. Subtract, we get 4. And we have a decimal here, and we need to bring down a 0. Now, in fact, at this point, I already know that the answer would be no, but let me just finish the problem. 8 goes into 45 times, and I'm sort of running out of space, but I would have to subtract 40 here, and I would get, because 5 times 8 is 40, so I subtract 40 here, and I get 0, and then I'm done with the long division, but I got a decimal result here. I did not get a whole number, so that means 8 does not go nicely into 252, and therefore, according to the rule on the reference page, 8 also does not go into 54,252. And again, we can check that very easily with the calculator just by doing 54,252 divided by 8, and we can see that we get a decimal result, which is not what we wanted. So we're not going to click on 8. But all of these were good, so let's click Submit there. Okay. All right. A new university library will have 86,760 books. The architect of the library wants to put the same number of books on each floor of the library. How many floors could the library have? Select all the possible numbers. So in order for each library floor, if we're splitting this number up, if we're splitting this number of books between a certain number of floors, and we want every floor to have the same number of books, then we want to make sure that the number of floors divides nicely into the number of books. So again, for this problem, we want to know if this number is divisible by each of these numbers. So you can check that using the rules on this reference page. We've done all of these numbers a bunch of times. Actually, I don't think we did 10 so many times, but that's an easy one. All we would have to do is check to make sure that the last digit is a 0. So I can check that one right away. All right, that's right over here. See if it ends in 0. But I don't think I'm going to go through the rest of this exercise. I think we did enough problems there. So I hope that was helpful. Reach out if you have any questions. I'm not going to finish this problem. We'll just leave it there. Again, reach out if you have any questions, and have a great day.